Hello, hello, hello. This is Quentin Hafner. I'm going to give you a little bit of a forecast, give you a little bit of dynamic schooling as well. Hopefully, going to be a little bit of everything. Let's just jump right into it. So, the first thing we're going to be looking at is our upper level pattern on the hemispheric map. So, we're kind of going to look for how many waves we have. This is to determine how fast our weather features are going to be moving to figure out how much change we can expect throughout the week. So if there's four or more, we say that it's more progressive, aka things are going to progress faster. But again, it's kind of relative. So how many waves you have will tell you how fast things are moving. And I see an obvious wave right here as so winds going from down to up. That's what we consider a wave in atmospheric science. Another wave right here, maybe another wave right here, and definitely a large scale wave right here. So that's four, so relatively slow moving waves, aka I'm guessing this next week in terms of weather is going to be fairly boring, but we can get a better look on the next couple maps. Before we go though, I want to note some important features. With this trough right here, probably, yeah, so we have more upper level divergence over here, and we get this from the thermal wind equation telling us, not the thermal wind, but we can tell this from the QG equation. So we generally, as a general rule, we expect winds to increase with height. This is because we have less friction as you go up in the atmosphere. And QG omega tells us that your vertical velocity is related to your differential vorticity advection, aka how your vorticity advection changes with height. If you have winds increasing with height, that means whatever vorticity, aka spin induced by the wind, is going to increase with height. So if we can determine the type of vorticity advection, we can determine the differential vorticity advection. Now this is mostly true. It's not always true, but it's mostly true. So over on the East Coast, again, large-scale divergence due to positive vorticity advection, because we always expect positive vorticity advection on the eastern side of a trough, and on the western side, convergence or negative vorticity advection or negative differential vorticity advection, aka sinking motion. So cloudiness over here. Clear skies over here. That's the general idea. We're going to get into why that's not true in this particular setup. Jumping right into it. So here's our 250 millibar map. So you can see here's our trough axes right here. So very strong upper level divergence over here, suggesting probably a low, more like towards the base of the trough, which will be it. Cause some weather for them. We don't really care though. We're over in Minnesota, so that what happens down here is kind of irrelevant to us. And you're probably thinking, oh, we should be in large scale convergence, right? Because we're on the western side of a trough. You would be right, except for there's, if you notice this little bit of a wave hidden right here, this ridge as we would call it, that's actually bringing us some enhanced cyclonic vorticity, so that's why you've been seeing cloudy skies today. And of course, we have to remember our thermal wind, which just basically says your wind is related to how much, what your temperature gradient is, aka the wind shear. So in areas where we have high upper level winds, we expect temperature gradients as well. So you can expect your fronts to kind of drape along down here, then down like that, then up like that. Going to, I guess let's go down a level first before we try to diagnose anything else. So notice that the wind speeds are a bit lower. So again, we have like 105 knots, and here we're looking like 55. So yeah, we have a lot of cyclonic vorticity advection, and it's increasing with height, which is exactly what we would expect for cloudy conditions. And again, it's positive because you see your trough axis is actually right here. Like overall, we're on the western side of a trough, but this trough right here kind of negates that. So we have to keep that in mind. So we are currently in upper level divergence because of that, hence the rain that we're experiencing. Moving to our upper level flow, this is just to observe where things are moving. that trough out on the west coast, that's going to be our big weather maker for this next week. So we're going to want to pay attention to that and where this moves. So as this moves over into the United States, that's going to cause a disruption. Notice this air following this trace like that. This is your convergence area, aka your high pressure area. That's actually going to probably force this trough up and is going to give us an even quieter week than we normally would. And again, that little bit of divergence right there. So that mostly zonal flow, but notice how you can still see that trough axis like that. Then just moving to the visible just to kind of confirm again. So trough axis like right here for our shortwave trough. And what do you know? We see clouds in this area supporting our upper level divergence hypothesis. And again, probably giving precipitation down there. If you'll recall, I mentioned a possibility for a low. There's your low over that large scale divergence over here. Obviously much stronger in our area. So I wonder if they're getting kind of heavy rain, maybe around there based on those clouds, and maybe down here even. Again, associated with that trough, we don't really care. They don't really matter for us. That's going to be moving out into the Atlantic Ocean, and it's not going to matter. Alrighty, so I think the next thing we're going to look at beyond visible is we're going to look at radar just to verify precipitation. And what do you know? We have precipitation over our area. Completely expected this. That makes sense with our shortwave trough. Again, that's kind of more like right along here. There's that heavy rain associated with that upper level divergence. Again, doesn't really matter for us. But yeah, so that's why you've been getting some rain showers today, is just because of that shortwave trough moving through. And so what does this mean? It means that your Sunday, the rest of your Sunday is going to be mostly cold with relatively cloudy skies. And that's going to change over the few days. And I think the next thing we're going to want to do is address some of the questions we want to answer. So we notice we have, going back to our, let's go back to this one. So a couple questions we want to answer is, we have this zonal flow right here, and we want to know how that's going to change, aka, is this going to change and bring in different types of vorticity, causing changing upper level conditions, leading to, say, rain or clouds or different things like this. And we're going to look at this on a day-by-day level. And we can't just look at upper level plot. We can't just look at our observed, right? Because we have to look into the future. So we are going to shift to the GFS model, or the Global Forecasting System. Overall, in terms of precipitation estimating, it sucks, but you do with what you have. The good news is its upper level plots are usually in the right spot, so we can actually look at this and infer where our precipitation is, just knowing that if we look at raw data, raw model output, that's probably going to tell us that precipitation is in the wrong area. So I've already went over Sunday. Let's just jump right into Monday. So here is that shortwave trough embedded in our flow. So here's that divergence area, convergence area. Note what happens. So as we move into Monday, it actually tilts down. It starts to dig down and kind of put us more in a convergence area. So overall, what that means is Monday you could probably expect, okay, so that's moving through, so probably warming temperatures with limited cloud cover and maybe some stronger winds. We can, of course, try to verify this with different model output. So going on Monday, yep, that's kind of what I expected to happen. So highs maybe about 60 degrees tomorrow, relatively light winds and limited cloud cover. I think that's going to be the story of Monday. Then we can switch over to Tuesday, and again, we always start from our upper level charts because that's going to tell us what's going to happen at the service. So here's moving into Tuesday, and yeah, this is difficult to suss out. I'm going to do my best anyways. So we're shifting to lower winds. That's going to give us more negative differential vorticity advection. So I suspect that during the day, this is going to mean relatively clear skies, but that's probably going to give way to cloudier skies and windier as this jet streak moves out of our area. We can try verify this, of course. I should mention temperature. Temperature doesn't, based on our wind placement, I expect our front to just generally follow the wind shear, and you're noticing that not a huge shift from the Monday to Tuesday. So I kind of wonder if wind temperatures are going to remain mostly similar. All right, so what's this? Oop. Yeah, so here's Tuesday. Yeah, what do you know? Maybe so over your forecast area. Yeah, literally the same thing basically. Light winds. Good chance for mostly clear skies shifting to cloudy skies during later in the day. High of maybe about 60, similar to the yesterday. Not a huge. So Monday, Tuesday, very similar. Let's go into Wednesday. Oh, Wednesday's interesting. Okay, good. I'm glad Wednesday's a little more interesting. All right, so Wednesday, notice this little bit of a short wave. Again, where do we expect our convergence and divergence? Right here, here's our negative vorticity, so here's where we're going to expect our convergence. Here's our divergence. Frontals are roughly going to follow our jet streak. So this is I hope you can see that this is very strong winds, so AKA very strong convergence, especially towards the surface, and thus limited clouds based on frontal placement. I actually wonder if, that's a tricky one. So we may get warmer because we have less clouds. Overall, the air mass looks the same. We might get warmer because we have less clouds, but we could also be cooler due to radiational cooling, and in the fall, it's kind of difficult to tell which is going to be your dominant factor. We can just kind of take a peek and just basically cheat a little bit. And okay, it does look like we should check the flow. Okay, I'm dumb. You can see more northerly flow right here. That's going to lead to cold air advection. So that's why you're a bit cooler, maybe a high of about 52 on Wednesday. Relatively clear skies throughout the day. Maybe a couple high clouds, but overall just clear. And I would expect probably a bit windier on, maybe a little windier on Wednesday, but again, nothing too crazy. Now let's move into Thursday. Ooh, Thursday. Okay, finally, something exciting. Okay, draw our trough axis again. What do we notice? Actually, here's our trough axis. What do we notice? We have our convergence over here and divergence over here. Relatively weak winds, aka not a lot of cyclonic vorticity advection, so not a lot of large-scale support. Probably a cold front associated with this. Again, thermal wind equation tells us that your fronts are going to roughly follow this. We expect colder air to the north, so when you see a bulge down like this, following jet streaks, you expect colder air to be behind them. So here's your cold front right here. And yeah, with that cyclonic vorticity advection along this area too, this all suggests overall rising motion and possibility for some showers. We better double check moisture though, because that could change everything. Give this a second to load. I don't like that. If there's moisture, so again, this is Thursday. It looks like it's going to be, so it's going to be overcast all day Thursday, just because of that trough moving through, leading to that upper level divergence. But notice this dry slot right here. So any precipitation that forms to reach the surface, it's going to have to fall all the way through this, and it's likely going to get evaporated. Because of that, I do not expect much precipitation. There could be some scattered precipitation on Friday, but overall not much. I expect cold. I mean, so sorry. We're talking about Thursday. Thursday can kind of expect maybe colder temperatures just because of that approaching cold front. And yeah, you see kind of a high of 48 for Thursday. Winds are going to be quite a bit stronger from the south, and you're like, why is it going to be colder? It's just because of that air wrapping around. So you're actually dragging in cold air that's adiabatically warmed, and then you're pushing it from the south, which then adiabatically cools it. So again, a bit cooler on Thursday, and then as we move into Friday. So again, Thursday night, watch out for a little bit of precipitation. It's not going to be much. Most of it's going to dry up. But moving into Friday, so notice nothing. There's no winds at all. So there's no convergence or divergence, aka I expect scattered clouds throughout the day. Notice, I wonder if they're going to be high clouds. We can actually take a sounding and just check real quick. Oh, that is. Oh, we gotta double check that. That looks like a rain profile. But we gotta double check that. Okay, so yeah, there's with that cold front, little bit of precipitation. It's not gonna be a lot. I wonder if I just took the sounding at the wrong time. 12Z. That's completely fair, I think. So maybe even a little bit of precipitation in the morning, and probably cloudy skies throughout Friday as well. Cooler temperatures, though. I think that's going to be the headline of Friday. Cooler temperatures. Winds probably from the west. We can verify this just going to surface and temperature. All right, here's kind of your Friday. Yeah, so high of about 35 degrees. Winds a bit stronger. Looks like they're coming more from the north than the west. So that's going to enhance your cold air advection, aka pulling from the north. So overall, colder Friday relative to Thursday. Now let's move on to Saturday. Okay, Saturday looks more of the same kind of. Doesn't look like any changes. Maybe a little bit if you're generous and you draw your trough axis like this, maybe a little more convergence, so maybe a little bit less clouds. I wouldn't do that. I just saying you could say that. AKA similar temperatures on Friday, maybe a little bit more warm advection from the south as this system moves by. And Saturday, nope, it's literally the same picture, maybe high of like 33, 34. So yeah, it's just, I don't know, it's kind of a blah week, just not a whole lot going on. Now, okay, that's funny. I love this. Again, draw your, so this is more like Sunday. Draw your trough axis, and where do you expect things to be? Well, here's your positive vorticity advection, aka they could get quite the storm over there. And look at us. That is a lot of anticyclonic vorticity. Again, I expect wind to increase with height. It'd be weird if it didn't. So a lot of anticyclonic vorticity, aka Sunday's going to be clear skies. There could be a Sunday. It's difficult to suss out. Sunday might be colder just because there's so much northerly flow, but this is a front giving way to warmer temperatures, so that's going to be difficult to suss out. Let's actually see what the model's saying. Yeah, okay, so it is going to be primarily warming. So here's that belt. If you go back, there's that belt going along like that, aka your warm front nose. That's going to be working in its way. But yeah, relatively static temperatures on Sunday. Expect clear skies just because there's no upper level forcing. So that is your forecast. Let me know what you think. Quick rundown.